All right, let's take a look at question number 8 and, no, 7. Yeah, I haven't done 7. We'll do 7 and 8, and then I may do 9 in class with you. All right, so we're doing implicit differentiation. Okay, now this one involves natural log already, like it has ln in there, and it's a product. So if I wanted to, I could go ahead and separate that into ln x plus ln y, natural log of x plus natural log of y, plus the 5x equals 30. I haven't done the derivative yet. Remember, don't start doing the derivative on any piece of it until you're ready to do the derivative on all of it. Now I'm going to do the derivative. Okay, so the derivative of ln x is 1 over x times the derivative of x, which would be 1. Derivative of the natural log of y will be 1 over y times the derivative of y, which would be y prime, because we're doing the derivative with respect to x. And then derivative of 5x would be 5. The derivative of 30 would be 0. Okay, so the 1 over y prime is going to stay put. But I'm going to subtract the 5 and the 1 over x times 1, which is really just 1 over x, from both sides. Right now, at this point, I need the y prime by itself. Okay, so to get rid of the 1 over y, I'm going to multiply by y. But if I do, I have to do that on both sides. Okay, so that cancels out and leaves me y prime like I want. And then here I just have 5y minus a y over x. Okay. All right, now that is not as pretty as I would like for it to be. Okay. Because it's got 2 terms in it. I would probably take that if you left it that way. But I could clean it up a little bit if I wanted to get common denominators. I could think of that as being over 1 and multiplied by an x, top and bottom. Then I would get a 5xy minus the y all over x. All right, I feel like there's an issue somewhere, and I've got to go back. Let me go back and look. 1 over x times 1, so that's okay. 1 over y times y prime plus 5 equals 0. So all that's okay. Just double checking myself. Okay. Then here I would leave the 1 over y prime. I subtracted. This should be a minus right here. I subtracted the 5 from both sides. So that should have a minus on it. Okay. So that would be an okay way to leave your answer, or if you left it in factored form, maybe factored out a negative y. I like to sometimes go all the way to the factored form just in case there's something else that I can cancel out. Okay, so either of those. But just be flexible. You know, when you're looking at CalcChat, checking your answers in the back of the book or with CalcChat, you might be on the right track and just have it in a different form. All right, now that feels really weird compared to the way I did it before. But anyway, that looks great. All right, let's go ahead and take a look then at how, even with implicit differentiation, you could ask for this to find the slope of the line. You can be asked to find equation of the tangent line, just like we were in earlier problems. Where's number 8? Here's 8. This should really be implicit differentiation right there. Okay, so we could be asked to get the equation of a tangent line. All right, so if we were, but we had a problem where it was hard to do it using explicit differentiation, then we would just come in and do the derivative with respect to x with each term. So this would be a 2x plus 1 times y plus x as is times the derivative of y. Both of those are just the derivative of xy. And then the derivative of y squared would be 2y y prime, and the derivative of 4 would be 0. So just like on the others, you would take a moment to kind of clean things up a little bit, maybe put the x, then the y prime. Okay. Look for the y primes you got. Keep them where they are. But move the 2x to the right, so subtract it. Then factor that y prime out, which means you have an xy plus 2y left. And once you divide by that xy plus 2y, you'll have negative 2x over xy plus 2y. Okay. All right, let me double check. 2x plus y plus x y prime plus 2y y prime equals 0. So that step's good. This step, I feel like oh yeah, I messed up on that right there, I realized. Okay, so hang on a second. I don't want to have to do the whole video over again. So let me just fix that, okay? So let me just fix that from there. So I'm going to start from here, okay? All right, no worries. It only takes a second. That was a plus right here. Okay, so I needed to keep it separate. So that's a 2x plus y, then plus x y prime. Okay. So these y primes stay. And I'm going to move the 2x and the y over. So I'll subtract them both. And then I'll factor out the y prime. So the y prime would wind up equaling negative 2x minus y all over x plus 2y. Negative 2x minus y over x plus 2y. Yeah, that looks good. All right, now this is really fun. This is cool. It's still the same concept. So that's the general formula for the derivative at the formula that would give you the derivative at any spot on that original relation. The thing is, there's both x's and y's over here now, but no worries, we have both x's and y's here. So y prime at that ordered pair 2, 0 can be found by just plugging in 2 for x and 0 for y. And this is, remember, is going to give us our slope, isn't it? So that's going to be a negative 4 over 2, or negative 2. Then we'll come back up here and we'll think, okay, so we know the slope at 2, 0, the value of the slope is negative 2, and we have this point, so we can find the equation of the line. Okay, and we wind up with y equaling negative 2x plus 4 for our final answer on number 8. All right, let me see if I can tell how long the video is right now. Can't tell. All right, let me go ahead and work on this one, but I'll probably stop it and do this one in class. I'll get you to a certain point and then I'll finish it in class. This one we're trying to do a second derivative. So we start out by doing the first derivative. So we do 2x times the y as is plus x squared times the derivative of y with respect to x minus 4 equals 0. So I went ahead and did the derivative at that point. So x squared y prime would equal 4 minus 2xy. And then y prime would equal 4 minus 2xy divided by x squared. Okay. Now, at this point, you could do the derivative, you're trying to get a second derivative. So you could do the second derivative from there, right? And just use the quotient rule on this right here. So that's an option. But I know what I like to do, so I want to share it with you. I like to bring that x squared back over by multiplying it on both sides. I like to back up a step. I'd like to do my second derivative from here, where I don't have to use the quotient rule. I can just use the product rule. And then I'm going to be thinking about taking that and just going one more time. So the derivative of x squared would be 2x times y prime as is, plus x squared as is times the derivative of y prime, which would be y double prime. Derivative of 4 would be 0, and then product rule again. The derivative of negative 2x would be negative 2 times y as is. And then I would have the negative 2x times the y prime there. Okay? So I'm working on the second derivative at this point. I've already done the first derivative. So one option is to kind of back up a step and do the derivative using that, starting from there. Because this is what you want by itself. Okay? So I could do that. All right, now if I did that, then at this point I'm just trying to get the y double prime on a side by itself. Okay, so I'm going to leave it where it is. Okay, and then I'm going to take what I already had and write it down. But then I'm going to subtract another 2x y prime. So at that point, I'm going to have negative 2y minus 4x y prime. Because those are like terms, aren't they? Okay. All right, now I'm trying to get y double prime. So I'm going to divide by the x squared. You might think that's okay, but notice that the directions, they really said in terms of x and y. Like you're not even supposed to have a y prime in there. So what I'm going to do is right here where you see the y prime, I'm going to replace it with that. Okay, and that's going to make for some messy simplifying. So let me get ready for that. So now I'll have my y double prime equals negative 2y minus 4x, and I'm going to go back to where the y prime was, which was where? Let me find my y prime. And I'm going to replace the y prime with 4 minus 2xy over x squared. And then there's still that x squared in the denominator. Okay. All right, now you can clean that up a smidgen by realizing that one of those x's would cancel, and you'd have just x to the first power down there. Let me erase that line. So one of those x's would cancel. So you'd have negative 2y minus 4 times 4 minus 2xy all over x. And then what you notice is you have a little fraction with the denominator of x. So multiply the top by x and the bottom by x would be a good way to get rid of it. All right, so we wind up with negative 2xy minus 4 times 4 minus 2xy, because the x's would be gone, over x to the third. Gosh, almost done. So that's a negative 2xy minus 16 plus 8xy over x to the third. So that's 6xy minus 16 over an x to the third, because those are like terms. So I can put those together. Wow, it's interesting that it cleaned up that nicely. So there were options on how we handled that. I just wanted to share with you how you might handle the ones where you have to do a second derivative, and this is one way to handle it. But you have to clean them up if you have complex fractions like we did here. We had that denominator of x. We had to multiply by x to get rid of it. Okay. So our final answer on that turned out to be 6xy minus 16 over x to the third. Would not be okay to leave the y prime in there.